We're going to take a look at polynomials. Here's an example of a polynomial. In this case, it's a trinomial, tri meaning three, and we have three terms. Your terms are the things that are added and subtracted together. Now, as we look here, we need to talk about some terminology. We have a constant up here. In this case, our constant is the 2, because that's the one term that never changes based on what x is. Because if x is 0, this term is 0, this term is 0, but this term here is still 2. If x is 2, this term would be 40, this term would be minus 14, this term here would be still 2. So no matter what x is, it has no effect on this term, so that's why it's called your constant term. X is referred to as your variable in this problem. Your coefficients are just the numbers in front of your variables, so that would be your 5 and your negative 7. Your degree is the highest exponent that occurs. In this case, it's a 3. Your leading coefficient is the coefficient, one of these two here, but it's got to be the one that's in front of your term with the highest power. Here, this is an x to the first. Here, this is an x cubed, so your leading coefficient is your 5 because it's in front of the term with the highest power. A polynomial is several terms added and subtracted together. Your exponents and your variables have to be positive whole numbers, so no fractions, no decimals, no negatives, and you cannot have variables in the denominator. Well, this one here, is it a polynomial? Yes or no. In this case, we're going to say no, and then you should also write the reason down, because we have a variable on the bottom. This one here, is it a polynomial? In this case, it is not, because we have a fractional exponent on a variable. This one here is not, because we actually have a fractional exponent on our variable, because your cube root of x squared could be written as x to the 2/3, where the denominator of the exponent tells you the root you're taking, the numerator of the exponent tells you the power you're raising it to. Is this one here a polynomial? In this case, it is. And you might say, well, it has a root. Yeah, but it's the root of a number. It's not the root of a variable. You have no variables in the bottom. When you look at your exponents on your variables, you have a 5 and a 6, and they're positive whole numbers. This one here, since we have two terms, we call it a binomial. This one here has three terms, we call it a trinomial. Once again, to simplify means to eliminate all parentheses and collect like terms. So that's what we're going to do here. Now, if this was a plus sign here, we could just drop the parentheses, because you can add in any order you want. But it's a subtraction sign, so we cannot just drop it. We actually have to take that subtraction sign and distribute it through. We're going to do nothing to the first part other than drop the parentheses. We're going to distribute through your subtraction sign, distribute it onto here. A negative onto a negative is a positive. A negative onto a positive is a negative. And then all we're going to do is collect our like terms. Our like terms are those that have the same variables and the same exponents. So those are like terms. These are like terms. And these are like terms. So you can combine those together, and you get this. Similarly here on the second one. Distribute through your negative sign. Your like terms are your x squareds, combine those together. And your x to the first powers, combine those together. And your constants, combine those together. Here we're going to go ahead and just distribute through. So we're going to take our negative y times this, our negative y times this, and our negative y times this. Our negative y times our 4y squared is a negative 4y cubed. Our negative y times our 2y, a negative 2y squared. And our negative times our negative is a positive, and we get a 3y. Over here, when you have a binomial, two terms, times a binomial, two terms, all you have to do is FOIL. You're going to multiply the first two terms together. Your 2p times your 4p gives you an 8p squared. Your outer terms, 2p times the 1. Your inner terms, 3 times 4p. Your last terms, and oops, just a second here. Our last terms are 3 times our 1. And then we combine our like terms together. The only like terms we have are the center two, because they're both p to the first powers. Cannot combine it with this because that has a p to the second on it. So here, on this first one, we're going to have to do something similar to the foiling, but it's technically not FOIL, because foiling is only 2 terms times 2 terms. Here we have a trinomial times a binomial. You need to take your a squared times your a squared times your 2. Now you got to take your 3a times your 3a times your 2. Now you got to take your negative 4 times your a, and your negative 4 times your 2. Then you want to go ahead and combine your like terms. We have like terms here, and we have like terms here. We cannot combine anything together here because we have no like terms, because these have different exponents on them. So over here, all we're going to go ahead and do is just distribute through your negative x times your 3x cubed, your negative x times your negative 2x, your negative x times your 5. So we're going to FOIL our 3x times our 5x, our 3x times our 1, our 2 times our 5x, our 2 times our 1. Combine our like terms of the middle two. Here we're going to take our x squared times our x squared times our 4. Now we're going to take our 3x times our x, and our 3x times our 4. Now we're going to take the negative 2 times the x, and our negative 2 times the 4. Combine together our like terms. Our like terms are the x squareds and the x to the first powers. Then we want to go ahead and just combine those together.